Imagine a sky that erupts like a living beast. A camera captures the moment, and you feel the shock. Extreme weather isn't just news. It's raw, untamed power. Every flash, roar, and swirl tells a story of nature's fury. First, let's chase the most infamous tornado. A funnel cloud descends, twisting like a giant corkscrew. Doppler radar spots the rotation, but the eye sees the chaos. When the vortex touches ground, it becomes a tornado. In Oklahoma, a 2013 video showed a house lifted like a toy. The wind speeds exceeded 200 miles per hour. That's faster than a Formula One car on a straight. Debris spins inside the vortex, creating a deadly carousel. The camera's slow-motion replay reveals each piece spiraling. Why do tornadoes form? Warm, moist air meets cold, dry air, creating instability. The clash creates a horizontal spin. A strong updraft tilts that spin vertical, forming a vortex. If the updraft stays strong, the vortex tightens. The tighter it gets, the faster it spins. That's why the most violent tornadoes look like razor-sharp columns. Now, shift to the ocean's most massive storm. The hurricane. Satellite footage shows a massive eye, calm and eerie. Around it, clouds swirl at unimaginable speeds. In 2017, a drone flew into Hurricane Irma's eye wall. The video captured rain slashing the lens like knives. Wind gusts topped 180 miles per hour. Storm surge flooded entire coastal towns in minutes. The pressure at the center can drop below 920 mD. Lower pressure means stronger winds, because air rushes to fill the void. Hurricanes feed on warm water. Each degree Celsius above 26 C fuels more energy. When the sea surface cools, the storm weakens. That's why scientists watch ocean temperatures closely. A recent clip from the Pacific showed a storm intensifying in just 6 hours. The clouds turned from fluffy white to dark, towering towers. Lightning crackled inside the eye wall, a rare sight. Speaking of lightning, let's dive into the electric dance of a supercell. A supercell is a thunderstorm with a rotating updraft, called a mesocyclone. It can live for hours, spawning tornadoes, hail, and massive lightning. A 2019 video from Kansas captured a bolt that split the sky. The flash illuminated a field of corn, turning it into a ghostly forest. Each bolt traveled over 5 miles in a fraction of a second. The temperature inside a lightning channel can reach 30,000 C. That's hotter than the surface of the sun. The air expands explosively, creating the thunder we hear. Hailstorms are another spectacular display. In 2010, a South Dakota camera recorded hail the size of softballs. The stones bounced off rooftops, creating a metallic drumbeat. Hail forms when strong updrafts carry water droplets above the freezing level. The droplets freeze, then fall, gathering more layers of ice. If the updraft stays strong, the hail grows larger. The biggest recorded hailstone measured 8 inches in diameter. Blizzards bring a different kind of chaos. Whiteout conditions erase the horizon, making navigation impossible. A 2022 dashcam from Minnesota showed snow drifting at 40 mph. Visibility dropped to less than 10 feet. Snowflakes can be as complex as tiny crystals, each unique. When they accumulate, they create a massive insulating blanket. That blanket traps cold air, intensifying the freeze. Waterspouts are tornadoes over water, and they're just as mesmerizing. A 2018 GoPro clip captured a waterspout forming off the Gulf Coast. The funnel rose from the sea, swirling turquoise water. Birds fled the column, while fish were lifted like balloons. Waterspouts can transition to land tornadoes if they move inland. Dust storms or haboobs turn deserts into moving walls of sand. In 2021, a drone flew through an Australian dust storm. The camera showed particles swirling like a brown tornado. Visibility dropped to a few meters, and engines struggled. Dust particles absorbed sunlight, cooling the surface below. That can create a temporary temperature dip of several degrees. Fire whirls, also known as fire tornadoes, combine heat and wind. During the 2020 Australian bushfires, a fire whirl rose 200 feet. The video captured flames twisting into a vortex of orange. Hot air rises rapidly, drawing in surrounding air and creating rotation. If the rotation tightens, the fire whirl can become a destructive tornado of fire. Now, let's explore a rare phenomenon, ball lightning. In 2014, a security camera in China recorded a glowing sphere hovering near power lines. It floated for seconds before vanishing without a sound. Scientists still debate its exact nature, but many think it's a plasma bubble. Volcanic eruptions also produce extreme atmospheric effects. A 2018 eruption in Hawaii sent ash clouds soaring to 30,000 feet. A time-lapse camera showed the plume expanding like a giant mushroom. Ash particles can travel thousands of miles, affecting air travel. Ice storms turn everything into a glittering sculpture. A 2013 footage from Michigan showed trees coated in thick ice. Branches snapped under the weight, creating a cascade of sound. The ice forms when supercooled rain droplets freeze on contact. Sudden stratospheric warming can cause polar vortex disruptions. A 2020 video from Alaska showed auroras dancing at unusually low latitudes. The sky lit up in greens and purples, a visual reminder of atmospheric shifts. Now, why do we capture these events on camera? First, footage helps scientists study storm dynamics in real time. Second, it raises public awareness about safety and preparedness. Third, the raw visual power inspires awe and respect for nature. Modern technology has revolutionized weather filming. High-speed cameras capture lightning in microseconds. Drones fly into hurricanes, offering eye-level perspectives. Satellite constellations deliver continuous global coverage. Safety remains paramount for every filmmaker. Never chase a tornado without a professional storm-chasing team, Darwin. Always monitor local alerts before heading into a storm zone. Use sturdy, weatherproof equipment to protect your gear. When you watch these videos, remember the science behind the spectacle. Warm air rises, cold air sinks, and the planet's energy circulates. Each extreme event is a piece of a larger atmospheric puzzle. By understanding the mechanics, we can better predict and mitigate damage. Early warning systems, built on data from these recordings, save lives. Communities that respect the warnings often avoid the worst outcomes. So, the next time you see a funnel cloud forming on the horizon, pause. Think about the invisible forces colliding above you. Imagine the wind shearing through trees, the pressure dropping, the roar building. That moment, captured on film, becomes a lesson for us all. From the calm eye of a hurricane to the chaotic spin of a tornado, the planet never ceases to surprise. Our cameras are merely windows into its wild heart. If you love this whirlwind tour of extreme weather, hit like and subscribe. Stay tuned for our next video where we dive into the science of climate change. Click the link right now and keep the adventure rolling.